This is the second video for section 3.4, dividing whole numbers. So now we're going to talk about the different algorithms that we can use for division. So the first one just comes from using the definition of division. So we said that 24 divided by 4 equals some number, let's just call it x, right, for a variable, right? So this is true if and only if. So again, this is coming from our definition. This is true if and only if 4 times x equals 24. Okay, so now that we know that 24 divided by 4 is x, if and only if 4 times x is 24, well, from here, we can use our multiplication facts. Right, so if we have those multiplication tables memorized, then we would know that this means that x equals 6. So from here, we can take division and convert it into multiplication using the definition and find our missing factor that we needed there. Okay, the second way to do it is to use an array/partition model. Okay, so this array is coming from page 110, right, the second page of chapter 3. So if we have that Kathy has 24 cookies and wants to distribute them evenly among her friends, right, 4 friends including Kathy, how many should each child receive? So in this case, we would do something like this. Well, we have 4 children, so we can represent them each by a circle, where the circle is the cookies that they're going to get. And then we make this first one a little bit. All of these divided into 4. We have each of these representing one of the 4 children, and we're just going to go through and put 24 cookies in there. Right, so this is a lot like how you would deal a deck of cards. So I put 1 here, 1 here, 1 here, 1 here. So we've done 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oh, I accidentally put 2 in that first one. Let me go back. We'll start over because I miscounted. Okay. Let's start this on over, and we'll start from the beginning. So again, we're going to put 1 for each child and then move on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, this is how it should go. You put 1 for each child until you're done. Okay. So that is how this model works. So just like kind of with everything else we've done, it's really nice to have a list of steps of how to do this, right? So that you would know how you would explain it. And honestly, one of the best ways to learn things is to be able to teach them, right? That means you really understand what's going on. If you can make this list of steps to know exactly what you're doing, right? This goes back to our problem solving strategies where we monitor our plan and we make sure we always know why we're doing the next step. That's really how you know how to do something when you can do that. So the first thing we did here was we started with 24 cookies. So the first thing that we really did was create a space to represent each child. So we had, right, and each of these circles represented one of the children. And the second thing we did was distribute 1 cookie at a time to each child. And we repeated this until all the cookies were gone. And then, right, this is the part we haven't done yet. We need to count the number of cookies in each group. So in this case, we had 4 groups representing each of the 4 children, and there are 6 cookies in each group. So that means that we have 6 cookies per child, right? This is another way to represent the exact same division problem. We're taking 24 and we're dividing by 4. So in this case, we're taking 24 cookies and dividing it among 4 children evenly, so we can use this type of model, okay? The next model that the book talks about is this repeated subtraction model. So we could model subtraction using a number line. So we can also model repeated subtraction using a number line. Okay, so in this case, we still have 24 cookies. And now instead of distributing them among our friends, we're going to put them into goodie bags. But each bag will only hold 4 cookies. And we want to know how many goodie bags we need. So in this case, we make a number line. Again, sorry, let me redo that. We make a number line. And so we're going to go all the way up to 24 because we have 24 cookies. Okay, I really hope 24 is going to fit in here. I don't think it is. Okay, gotta redo this. Every number, I'm just gonna do a tick mark. I'm gonna write out the number for every other tick mark, just so I have a little bit more space. Well, sorry y'all, gotta get this under control. 1, 2, 3. So this is 0, 2. Okay, so now I'm just gonna go back and label every other one, just so I don't have to write as tiny on here. Okay, so, well, I guess I'll go ahead and fill them all in. Okay, so I went back, filled everything in. So now we can do a repeated subtraction. So we go all the way to 24, right? We add all the way up to 24 cookies. And now we're going to take 4 away at a time. So the first time we take 4 away. Okay, so we take 4 away there and get to 20. We take another 4 away and get to 16. We take another 4 away and get to 12. We take another 4 away and get to 8. Whoops. We take another 4 away and get to 4. And then lastly, we take the last 4 away and we get to 0. So now to finish this problem, we just have to count how many times we took away 4. And that is 1, 2, 3, 4, 5, 6. So we took 4 away 6 times, so we have that 24. And if we take 4 away, we take it away 6 times. Okay, so again, let's write out what we did. So the first thing that we did was we started with 24 cookies. And then we subtracted 4 at a time. So we subtracted 4 at a time until we got to 0, because then we can't subtract 4 anymore. And then we count the number of times we subtracted. And we subtracted 4 6 times. So that's how we do this one. So one thing to notice about these two problems, so they're really similar, but in this case, the repeated subtraction model, the quotient is the number of groups. So I'm just gonna write that. So here, the quotient is the number of groups. Okay, so the quotient is the number of groups, but up here, this quotient was the number of cookies. So up here, the quotient was the number of cookies. So this helps us determine our model, right? So we already knew the number of groups in this example, so we needed the number of cookies. So that's why we used this model where we already knew the groups and could draw them. However, in this model, we needed the number of groups, so we couldn't represent that by that model, so we used this one instead. So this was just kind of helping know what motivated us to use each model. Were we looking for groups, or how many things were in each group? Can help tell you which model is best to use. Okay, so that's all for this page, and we'll come back next time.